Welcome back to Algebra with Miss Swartz. We have another video today. We're continuing on with our absolute value equations from yesterday. So if you weren't with us yesterday or you are just watching this for fun, we can quickly review what we touched on yesterday, our absolute value equations, and how they can be separated into two parts. We talked about the absolute value of n is equal to 5 and how we could have two values of n that would actually make this equation true. It would be 5 or negative 5. So in the same way, when we have an equation that looks like this, we can have a couple options for what could be true here inside the absolute values that would make the equation true. It could be 7 or negative 7. So we can separate those into two parts. We can say 3x plus 1 will equal 7, and 3x plus 1 would equal negative 7, and those both are solutions. So we separate them into two parts. And a lot of times with absolute value equations, we get two answers. Now today might change that up a little bit. In a little bit, we'll talk about extraneous solutions. But for now, we're going to move on into absolute value on both sides of the equation. So I want you to look at this and think about it a little bit, just to challenge you. So if the absolute value of A is equal to the absolute value of B, if A is 4, I want to know what B could equal. Okay, so if A is 4, we know the absolute value of 4 is 4. So the options for B are either 4 or negative 4, because both of those absolute values would be positive 4. 4 equals 4 and 4 equals 4. So if A was negative 8, would that change anything? Okay, so the absolute value of negative 8 is 8. Could we have 8 for B? Yeah, because the absolute value of 8 is 8. Could we have negative 8 for B? Absolutely, because 8 is equal to 8. So as you can see here, when we have absolute values on two algebraic expressions that are equal, they're either going to be equal to each other, like we showed here, or they're going to be opposite of each other, like we showed here. And equal and opposite. So that makes it pretty easy because we don't have a lot to change when we're working with absolute value on both sides. So here's kind of our core concept. If we have an equation or an expression on one side and an expression on the other, remember A and B are just numbers where X is our variable, and C and D would just be numbers where X is our variable. If they have absolute values on both sides, we can split them into two again because we have that absolute value, and we can say AX plus B is equal to CX plus D. Okay, we just take away the absolute values, positive, positive, they are the same, so we can just set them equal. Or we can say AX plus B is equal to the opposite of what's inside here, so negative CX plus D. But as you can see, that negative applies to all of this. It's in parentheses. It's not just the CX, it's not just the D, it applies to all of this. So let's look at a couple examples of that. If we look at A here, we have the absolute value of 3x minus 4 equals the absolute value of x. So our first step would be to separate this out into two parts because we have absolute values. So we have 3x minus 4 is equal to, well, they can be equal to each other. So I could just say a positive x, or they could be equal to, they could be opposite of each other. So we would have 3x minus 4 equals negative x. Now I just need to solve both of these. So I have to use my knowledge of how to solve equations to work from here. I need to get my variables on one side, so I'm going to subtract x here. So I have 2x minus 4 equals 0. Don't let that freak you out. We're just solving this equation, so add 4 to both sides. So I have 2x equals 4. And I'm going to divide by 2 on both sides, so x will equal 2. Now, it's always good to check that. So plug it back in. 3 times 2 is 6. 6 minus 4 And look, I'm not showing every step. 6 minus 4 I know is 2, and the absolute value of 2 is 2. And then over here, I had to have 2, and the absolute value of 2 is 2. So I know I got that right. So I know this is an answer. It's good to work on checking your work. Over here, I'm going to add x to both sides. So I have 4x minus 4 equals 0. Then I'm going to add 4 to both sides. So I have 4x equals 4. And divide by 4 on both sides. So x equals 1. So now, 3 times 1 is 3, minus 4 would give me negative 1. The absolute value of negative 1 is 1. And then the absolute value of 1 is 1. So I also know this is a correct answer. So I can see that I have those both answered, and I'm good to go. So let's try B together because it looks a little bit different than the first one we did. I have the absolute value of 4x minus 10 is equal to 2 times the absolute value of 3x plus 1. We have absolute values on both sides. Okay, so we can say that they are equal to each other, just the way they are. But notice, this 2 is being multiplied by everything inside the absolute value, so I'm going to put those in parentheses. My other option is it's equal to its opposite, okay? But it's only equal to its opposite of the absolute value. So I'm going to say 2, and then I'm going to put in brackets a negative, because it's the opposite of this whole piece, 3x plus 1. If that confuses you, please ask a question. I can try to explain it a little bit better to you individually. So now I just have to solve, which can take a little bit of time here. I have to distribute, so I'd have 6x plus 2. I have to get all my variables to one side, so for me, I'm going to subtract 4x. So I would have negative 10 equals 2x plus 2. Then I'll subtract 2. So I have negative 12 equals 2x. And finally, divide by 2 on both sides. So negative 6 equals x. So that's what I think my first answer is. I might come back to check it after I'm done over here. So over here, I have 4x minus 10 equals 2, and then I'm going to distribute my negative. Remember, that's like a negative 1 out there. So I have negative 3x minus or plus a negative 1. Okay, now I can distribute the 2. So I have negative 6x plus negative 2. And then I can work with what I have. So I'm going to add 6x in this case so I can keep some positive variables. So I have 10x minus 10 equals negative 2. Add 10 to both sides. So I get 10x equals 8. And then divide by 10. So x would equal 8/10 or 0.8, or you could say 4/5, depending on how you want to write it. Okay? We really should check to make sure that these are right. Okay? Now with 0.8, that could be difficult, so you can use a calculator. It's okay. But negative 6 times 4 is negative 24, minus 10 would be a negative 34, and then it's an absolute value, so we'd have a positive 34. Then we'd have 3 times negative 6, which is negative 18, plus 1, which would be negative 17, but it was in absolute value, so that would be positive 17 times 2, which does give us 34, so that we know negative 6 is right. And we could do the same thing, but for sake of time, I'm not going to plug in 4/5, but if you want to, you should. All right, moving on. The next thing we're going to talk about is we have one more example of what we just did. So I want you to try this one on your own, and I want to see it. So I'm actually going to change it a little bit. I'm going to put absolute values here, and I want you to try that on your own. So the question that you're doing should be this. Okay, so try that one on your own. Now we're going to go ahead and talk about extraneous solutions. So an extraneous solution is a solution that you get that doesn't actually end up satisfying, is a word we can use, the actual equation. So I'm going to give you an example of what that looks like. Here we go. So if we look at number 10 here, we have x plus 6 equals 2x. Okay, so just like we've done, we're going to separate it into two parts. It's an absolute value, so I have 2x here, and then I have equals negative 2x. So now I'm going to get my variables to one side and subtract x, so I have 6 equals x. And then I'm going to subtract x here, so I have 6 equals negative 3x, so I'll have to divide by negative 3, and I'll get negative 2 equals x. So if I go back to check these, I should get true statements. If I don't, I know one of these is extraneous. So if I plug this in, the absolute value of 6 plus 6 equals 2 times 6. I would get 12, and 12 equals 12. So I know x equals 6 is a correct solution. If I plug negative 2 in there, I would get negative 2 plus 6 equals 2 times negative 2. Well, this is 4, the absolute value of 4 times is equal to negative 4. Is that true? Well, 4 is obviously not equal to negative 4, so I cannot include this in my solution. I cannot say x equals negative 2 is true. But I do need to show this work, and I need to figure that out. So notice how I've showed both sides of it. This is why I keep telling you, check your answer, because x equals 6 is the only correct solution here. So I want you to try 11 and 12, and let me look at them. Some may have extraneous solutions, others may not. So make sure you check your answers and then show me your notes. And then your homework is actually in your journal, okay? Page 20 and 21, it's just numbers 1 through 9. Just more practice with our absolute value equations. If you have any questions, make sure you come see me. Have a wonderful day.